I just want to cover software before we kick off into the webinar. So in regards to software, there is StudioRM, which everybody knows, and there is StudioRM Pro. In StudioRM, we have the process estimate, where everybody obviously sets up their estimation. And in StudioRM Pro, you then have access to Co-kriging. Now, StudioRM Pro is StudioRM plus the Advanced Estimation module and Supervisor. So this is actually a bundle, and the Advanced Estimation module can be bought on its own. So Co-kriging is only accessible to those that have access to the Advanced Estimation process. If you do not have this, you do not have Co-kriging. But if you do have Co-kriging, that is why you're here. So why Co-kriging? Okay, so there are several advantages with Co-kriging, but the main advantage is the fact that it's multi-threaded. That basically means that if you set up an estimation in ESTIMA and you set up the same estimation in Co-kriging, Co-kriging will be faster based on the number of cores you have on your computer. Because ESTIMA is not multi-threaded, it will only run through one core. So if an estimation in ESTIMA is taking you 24 hours and you flip it over to Co-kriging and you have 8 virtual cores on your computer, it will be 8 times faster than ESTIMA. So that estimation will only take you 3 hours. So this allows you to do a lot of iterations, and it's quick. So for clients that have huge data sets, or the estimation takes a long time, we do recommend this, or at least look into it. On top of that, its interface is quite user-friendly once you get to know it. Setting up soft boundaries, hide your restrictions, displaying your ellipse, you can do that. Importing the supervisor project into Co-kriging via the interface allows you just to suck in all your variography, so that just gets spat out as a variogram file if you want it. In ESTIMA, you have to do some post-processing to get your kriging efficiency and sort of regression. These outputs are simply fields that you tick on and off in Co-kriging, so a lot more simpler than that. Another big ticket difference is that ESTIMA only allows you 3 search passes. In Co-kriging, you can have more. So if you want to access Co-kriging, obviously you'll have the Advanced Estimation module, and to bring it forward, you just go to the Estimation ribbon, we'll head over to Advanced, and then we click Multivariate. This is Co-kriging. So both Co-kriging and ESTIMA have a front end and a stripped end as well. So this is the front end of Co-kriging. If I click on Interpolate, this is the front end of ESTIMA. It's called Estimate, but this is just the front end of ESTIMA. And if we type in ESTIMA, this is something that we recognize. And if I was to type in Co-kriging, I would see this too. So this Co-kriging is just that this interface is effectively Co-kriging, but with a flashy front end. All right. I'm going to run you through how to import your supervisor project. Then I'm going to run you through how to set up an EA estimation. And then we'll go through the process of importing an ESTIMA parameters into this interface and setting it up so it runs through Co-kriging. So how to easily flip it over. To import supervisor, there are 2 things you need to do before you click this import button. The first one is to create your scenario. So just hit Create New, and I'm going to call this ESTIMA to Co-kriging in the name. And I'm just going to quickly save these changes. And the second thing we need to do is go to Select Sample and pull in the data that we're going to estimate. So this is my Drillhole database. I'm going to estimate AU, CU, and in this deposit, there are 2 zones. And that's it there. Now I'm going to go back to Scenario Setup, and I'm going to click Import. So in Supervisor, I literally have that same compile in Supervisor, and it's got all the variography sorted out for it. So Co-kriging is smart enough that it doesn't matter if you set up your supervisor project as assay domain or domain assay. It'll do its best to take the parameters and suck it in. If I go to the review variography, this is from supervisor. It's done a pretty good job picking up my parameters. And it also tries very hard to make the job easy for you. So it's also picked up my searches, and then it's tried to be clever and sort out my EVA file. So if you're trying to set up your estimation parameters via supervisor, this is how you would do it. We're not doing that, so I'm just going to clear this all out. But it's just to let you guys be aware that the interface has the capacity to do this. I'm going to go to define custom zone, and this is where you make custom boundaries, so your soft boundaries. So let's say for zone 1, I want to see samples in zone 1 and zone 2, so I'm just going to click the 2 zones, add zone, and now this is my custom zone. So later on when I set up my estimation parameter, I will use this custom zone instead of the zones accordingly. We'll ignore bivariate statistics because we've done all our statistics in supervisor, and we're going to go to select prototype. Now, if you want to run a DA estimation in Co-kriging, this is where you do it here. So obviously we need to run an estimation to get our angles, and then when we have our angles, we can then run, and we're doing ordinary Kriging estimation, we can use the DA in our block model to inform our final grade estimation. What we need to do first is go to estimate angles. I'm going to pick up my block model that's already been made for me, and I am now going to select my angle data, which I've already made previously to this webinar. Self-explanatory, match up your coordinates. We're going to estimate true dip and true dip direction. I will restrict to field because I'm only going to run DA in zone 1. And it is through the rest of this interface where we set it up. You have the option for inverse distance nearest neighbor, subcell, parent cell, discretization, and then the search itself. This is going to be a isometric search, so just round beach ball. I'm going to dial this to 60 and then just make my min sample to 1, so it will populate. Once you're happy with everything you've got, we're going to hit estimate angles, and it's successfully estimated. Co-kriging is a benign dictator, so if you run through the interface, the block model output with angles will be auto-populated for you. Now, let's say I'm going to do a DA OK, and I want to ensure that my angles in my block models are being used. In dynamic isotropic fields, this is where I will set it up so that it will read my directions. And one thing we need to do before we do this is actually add Plunge to our DA model. I'm going to run a quick extra, and I'm going to have a Plunge field in my model. I'm going to use this formula here where my trip is greater than 0, true Plunge will equal 0. Just test that, have a quick run, it should do that for me, and now I have my model with my true dip, and plunge direction. Important thing to note about Co-kriging. So in ESTIMA, if you do not have plunge defined in your model and you only reference true dip and dip direction, ESTIMA will still run. What it will do is, if plunge does not exist in the model, it would then go to your variogram file and then take your plunge from your angles. Co-kriging does not do that. So if you do not have plunge in your model and you do not reference plunge, the estimation will fail. So you need to have it regardless. So I'm just going to re-reference this and make sure that everything is referenced accordingly. So first is my true dip and dip direction, second is my dip, and then third is my plunge. and this is where we define our output model. So this is my final grade model, and it's going to be DA-OK. All right, so I've prepped up this grade estimation to use DA. Now I'm going to go to parameters. In parameters, this is where I'm going to use my ESTIMA parameter fields, or parameter files, and use them to help me set up Co-kriging. So we're going to click Use ESTIMA Format, and then we are going to reference our ESTIMA files accordingly. In ESTIMA, you only have three. You have your ESTIMA, you have estimation parameter, the variogram, and the search. And I am going to click Import. Once it's imported, we're going to go through the other tabs, and we'll just go through what's been imported in and what changes do need to be made, because there are features in Co-kriging that do not have a comparative feature in ESTIMA, so adjustments are required. So in Define Estimation, I have my CU, AU of Zone 1, and CU and AU of Zone 2. So I'm going to just sit in Zone 1 for here. Obviously, define what type of estimation. It is univariate. We're going to keep the parent cell. In Co-kriging, the cell discretization is to each estimation, so you can change this. I'm going to leave everything alone. And if I want to use DA, so I'm going to use DA for Zone 1. I've defined it in my selected prototype, but I also needed to find it in my estimation setup. So I need to ensure that search volume is ticked on and variogram model is ticked on. And I will do that for AU as well. Once these are done, and I'll go back to my first one, we can head off to our field names. So our field names have our variance, the num sample, SFOL, and minimum distance, which is the outputs that you can get in ESTIMA. However, in Co-kriging, as you can see, you can get your kriging efficiency spat out and also your slope of regression. Important thing to note, if I click kriging efficiency, you can see that the variance has popped up. If I go off and click slope of regression, you can see the variance of Z star and the covariance of Z and Z star pop up. This means that if I want my kriging efficiency and slope of regression, I need to ensure that these other outputs have been selected as well. So kriging efficiency and slope of regression, that output is dependent on other fields being spat out in the model. In the interface, if you click on them, it would automatically click them up. However, if you are doing it by the macro, it is something you need to be conscientious of. What I'll do is I'll tick everything that I want on. Now, measure distance doesn't hurt. Since I have the opportunity, why not? I'll do the same for the other fields as well. And this one through here. Alright, so I'm going to get all the outputs that I want. If I want to use a soft boundary estimation, I go to this tab here, and back in Select Samples, Define Custom Zones, I defined a new zone 1 and 2. So in Define Sample, if I want to use my custom zone, I simply select 1 and 2. So my AU Zone 1 has a soft boundary going on, and estimation parameter 2 is my AU Zone 1. Sorry, that was CU, and this is AU. And so I'm going to have that dialed in for me. All right. Zone 2, I'm going to leave alone, but they're effectively the things that we need to be conscientious of. When we go to the variogram file, there is actually nothing you need to change. The difference between the variogram files between ESTIMA and Co-kriging are pretty minimal. And now I'm going to go into our defined search. So I'm going to go to this first search. This should look very familiar to everyone. So obviously this is my ellipse, that's my size, here are my angles, I haven't got any. This little display ellipsoid here just simply means you can display your ellipse. I'm just going to bring a wireframe in, so you simply just click on this button, click on the screen. hit this button here, an ellipse of your search will appear. So you can validate accordingly if you wanted to. I'm just going to remove this because we are not going to worry about that. The next tab along is the sample number limit. So this is where we define our min-max and also our passes. So you can see there are 3 passes in through here. If I wanted another pass, I simply click add. If I want to make changes, I can do so accordingly. So let's say I change that to 1 and 10. I hit apply and it will update. And if I want to remove, I simply remove. I'm going to leave this alone as it is. In through here is where we define our max key. Now, in select sample, your whole ID is effectively your max key field. So we will limit the number of samples that can be found by borehole ID. And if I go back through here, I have set it to a maximum of 4. So I've got a max key of 4 defined. The next tab we're going to go to is sectors. So in ESTIMA, you have octants. In COKRIG, you have sectors. Now, if you simply want to replicate an octant search from ESTIMA into COKRIG, all you need to do is enable sector method, the number of vertical sectors. So you're literally slicing the search straight down to get a ESTIMA octant search. You want to have 4 and split sectors horizontally ticked on. So effectively, I have 4 sectors. So like imagine a mandarin and I've split it into 4 pieces. And then the split sector horizontally means I've cut that in half. So now I've got 8 sectors, which is what happens when you turn on octants in COKRIG. The sector search has more flexibility, so you're not just trapped on 4. You can change that to 3. So you can then have it split into 3 sectors and then cut across. So now it's got 6 sectors that you can work with. But I'll leave that alone for 4. And then you have the maximum empty sector. So how many sectors will you let be absent of samples? I'm going to turn that to 4. And we have a keep all in blocks. We're not going to tick that on. The estimation goes a little bit haywire, so we don't recommend this. You can if you want. Please look at the help if you want to do that. And this only comes into play if you're running a COKRIG estimation, which we are not. Something we just want you to note that when you do turn on the enable sector methods, if we go back to sample number limits, we now have the optimum per search. So this search here has no octants on, so that's like 20 because the search is just one search. But now that you have octants or sectors, it's now, this is the optimum. So effectively what's happening here, so every segment, you can see up to 3 samples. So the maths behind this is whatever your minimum is and whatever your maximum is, it is divided by the number of total sectors that we have. So it's literally 20 divided by 8, and then it's rounding up to the biggest number, which is 3. So for each sector, because 5 divided by 8 is, well, it's going to round up to 1, you have a minimum of 1 and then a maximum of 3, or optimum in this case. Outliers. This is the tab you want to be in if you want to use those high-low yield restriction searches. To utilize it, all you need to do is hit enable capping, and then you have the option of setting it for high value, low value, or replace or exclude. Say that I've opted for a high value replace, and let's dial the numbers in 20 and 30. And I'll just pop this open. Okay. So if I selected high value and replace value, what's happening is wherever my value has been capped over 20, so the sample here is over 20 grams, within a 30 meter radius, any block that is within that radius will see the sample as the true value. So block 1 will see the sample as 100, and then it will see the sample as 10. However, block 2, which is beyond 30 meters, we'll see that 100 gram sample as 20. And obviously the value, any value less than 20 will be C as its true value. So that's effectively a cap and replace. If I opt for an exclude value, what is happening now is a cap and exclude. Block 1 behaves the same way, but block 2, where it's beyond the radius of 30 of the capped value, no longer sees that sample. So it needs to look elsewhere. So there's just different ways to deal with your outliers, and it will fetch your metal accordingly. I'm going to leave this as known as high value, and let's leave it as a replace value because I don't want to be too aggressive. Once that's been defined, we effectively just need to go to run estimation. This is the summary. Note that with the parameter files, we have 5 parameter files now, not 3. And the zone parameter file only comes into play if you're using a soft boundary. Your sample out file, this is where you get your sample out file through here, so name that accordingly. And once you're satisfied with everything, we're going to hit run estimation. When that estimation is run, so Co-krig is complete, what we should have is our estimation by Co-krig with DA. Okay. Now, that is effectively us flipping ESTIMA into Co-krig. I'm just going to highlight the key differences between these two processes, how they look in the macro and how their parameter files look. If we open up macro, this is just a stock standard ESTIMA, and then this is what we've done for this webinar. So we've done a DA estimation, and then we did an extra statement, and then we did a grade estimation using DA. We are probably only really interested in this comparison here. So you can see straight away that all the fields that were initially in the ESTIMA macro no longer are in the Co-krig macro because we've actually moved a lot of them into the parameter files themselves. So, for example, in ESTIMA, if you're running DA, all you would have to do in the ESTIMA SPAR would have been to define your S angles here. True dip, dip. True dip, dip, and plunge. In Co-krig, if you're using DA, it needs to be defined in the macro and also in the parameter, but not in the search parameter. It is defined in the estimation parameter as S and isolang and as the search and the variogram. So parameters have been moved around depending on what you're using. Another thing to highlight is your discretization points and whether you're using a parent cell estimation or a subcell estimation. All of that is defined in through here. And your at parent is defined here. In Co-krig, they're no longer defined in the macro. They're defined in the estimation parameter file. So they're defined in these fields here. So here's your parent, and here are your discretization points. The max key is the same across Co-krig and ESTIMA. You defined it in both the macro, so here's your key fields accordingly, and it is in the SPAR where you define the value. We've discussed this already, but one of the key big differences is the fact that ESTIMA uses an octet search and Co-krig uses a sector search. So just by default, it's just going to be different. So if we look at the search part in ESTIMA, if you're setting up an octet search, it's just these parameters here. However, if you're using sector searches in Co-krig, it's defined here. So N sector split, empty sectors, etc. Your min and max per sector is effectively your min and maximum values divided by the number of sectors. So it's 4, then split to 1, so you literally double this number. Capping cannot be done in ESTIMA via the estimation process. It can be done in other ways, but in Co-KRIG, capping is defined in your search parameter. And they are these values through here. So one was high yield and a replace. Obviously go to your help if you want to figure out how to set it up the other way. Soft boundaries, those parameters have their own field and they live in the custom zone. So there's a Z parameter field. So this is us defining the soft boundaries for zone 1 for AU and CU. The other thing to point out, and this is so that people are just conscientious of it. So this is your VPAR parameter file for ESTIMA. And then this is your VPAR parameter file for Co-KRIG. They are effectively the same. The thing I want to highlight is grade and grade 2. So these are here because of the co-kriging capacity in Co-KRIG itself, hence the name. And the reset number. So re-ref number is an ESTIMA field. Reset number is a Co-KRIG field, and grade is also a Co-KRIG field. Always ensure you have reset and re-ref. Just at this point in time, it's good to have both. And I want to highlight the variogram for our CU and AU. Because we've imported this was set up with a supervisor import, you have it for both zone 1 and zone 2. But they're effectively the same. But if you are setting up a estimation in Co-KRIG, and it's not uncommon for users to have an AU field and then an AU cut field. So you want to run 2 estimations, one with the full data set uncut and one with the data set where you cut it. You would use the same variogram file. So in ESTIMA, if I was running and this is for CU, if I was running a CU estimation, so I had CU and CU cut, I will just, in my EPAR file, reference the variogram 1 for both. You can't do that in Co-KRIG. Because of the grade, and the grade here, the variogram must exist for each estimation field in the input file. So if in the input file, so the Drillhole file, I have a CU and CU cut, and you want to use the same variogram, you simply can't just reference 1, because this is tied to the input field CU. You need to actually add a new record. You need to duplicate it. The grade will reference whatever the input field in the Drillhole is, and then the VSET number and ref number needs to have its own unique number. So this is something that users need to be wary of if they want to use the same variogram for different input fields they want to estimate from the Drillhole file. Yeah, and that's pretty much it for Co-KRIG.